This is a quick tour of the parameter optimization procedure in NITA. So this is in the step 2 tab and step 2C. And caveat, this is kind of experimental and I don't really guarantee great results, but it's useful in some cases. And so I will show an example, and it's kind of an active area of potential improvement. So I've loaded up the demo data set and I'll visualize some points here. So this is our oil palm data set. And you can see we have a nicely fit disturbance. Over here, we've got, this is okay. Characterization, got some extra segments in there. Maybe miss a disturbance in the lower left. So, we want to think about what we're hoping to accomplish and then try to optimize for that. And so in this case, what we're trying to accomplish is really the accurate depiction of disturbance and recovery processes associated with the oil palm planting. And so a lot of it's going to look like this upper left corner. So we can look at a few more. So this one in the upper middle is typical also. So, some of these don't look too bad, but look at 15, you've got a lot of probably extra segments in there. And so it'd be nice to clean this up a little bit. So I would choose a few segments that I'm most interested in improving and kind of characterizing the process. And I'm going to hand draw them essentially based on a combination of my local knowledge, because these points are supposed to be ones that you actually know something about, and also just how the data look in this pixel, looking at the Landsat NBR information. So I've chosen 5 points to work with that I think are interesting, and I'm going to switch to draw trajectory. And it's going to pop up this blank screen, and now I'm actually going to click the breakpoints myself. And so this is a bit of an art, but it doesn't matter that much. Just generally try to characterize what the disturbance is and when it happens. So these red plus signs come up where the breakpoints are, here, here. You don't want to overthink this too much. Slog pond, kind of going with my best guess at what this should look like and trying to characterize that key disturbance feature, not worrying about everything else. This one's a tricky one. It looks like there is a disturbance there. Big clearing here. And finally, got a 2016 disturbance. And then it looks like another one subsequently. All right. So now I'm going to load a default parameter set. I click that and it pops in the kind of the values that will be used in the optimization. And so you can play with some of these also, or you can just let the default values go as a starting point. And so the more values you put in here, the longer the optimization is going to take. One thing I did change, I changed this to Savitsky-Golay rather than move CV because I'm trying to characterize acute disturbances, and Savitsky-Golay is seems to be a little bit better for that. So it's going to exhaustively search all of the parameter combinations that I've sent in here, so it can take a while. Let's submit this and see how it goes. Okay, so that just took about 15 seconds or so, and on 16 cores, mind you, and popped up the optimized parameters. And now, so what this is optimizing on is simply the root mean square error between the algorithmically determined fit and the hand-drawn fit based on the breakpoints I entered in. And so there's some issues with this. It's not ideal for, actually optimizing what you're trying to optimize. In this case, might be like the disturbance date or the disturbance magnitude. It's just minimizing that RMSE. And the other issue is that it's going to generally not be super parsimonious in its fitting because it's going to just do the best job it can to match the trajectories. And so it doesn't care how many segments it takes to do that. So one way to deal with that is just to only allow it to have fairly high penalties here so it doesn't get too crazy. So I'm going to save these to the configuration file. So that's overwriting. So be careful there. And then we'll visualize the new set of trajectories. And things look pretty good here. So this fit is still good. This log pond fit is at least matches up with what I thought it is in reality, characterizes the disturbance well. We were still not able to characterize if there's a disturbance in this network of canals, so that couldn't be picked up. This land clearing worked well, and then this double disturbance also picked up pretty well in primary forest. So that's it for now, and hopefully we'll update this to be a little more robust in terms of the criteria and multiple criteria even for optimization in the future.